go. Great. Welcome and thank you for having me here. As already said, my name is Joerg Domaschka. I'm from Ulm University in Germany, and I'm supposed to present what we call Cloudiator, which is work actually done by 3 of my PhD students, Daniel Baur, Seybold, and Frank Griesinger, who actually cannot be here today, sadly. Good for me. So if there's anything flawed in what I say, blame them. If there's anything good, it's tell me. Before we start, let's just make our financials happy by telling you that most of this work has been done within the Passage project, European funded project. So, Cloudiator, what is this about? The title already said it's cross-cloud deployment and runtime engine, and why would you need something like this? As you heard probably in the last few days, the cloud hype, well, I wouldn't call it hype anymore, but cloud is still at its peak. Some say it is even past the peak and is slowly going down, but still we're facing several huge problems that have been here for 5 years, 6 years, I don't know. Particularly vendor login, the fact that you cannot really compare different cloud offerings because a virtual CPU for one cloud operator is not the same as a virtual CPU in another cloud operator. There are incompatible APIs that you have to use for getting your virtual machines. So everything I'm saying here is about infrastructure as a service. There's no platform as a service, no software as a service. This is out of scope for this talk. And sometimes cloud providers don't fit for your applications or for parts of your applications. So you want to be, rather as a user, you want to be flexible. You want to be able to move your database here, and if conditions change, you want to move it over there, maybe, or same for your web server or your application server. So what you want to have then is, or what you have the need that you adapt your application to this changing environmental conditions, and also, well, scale up, scale down, add new instances or add new instances in other clouds. And eventually you also want to have some awareness of the application state. So you don't want to deploy your application and say now it's running, but you want to have it monitored and react to favors or conditions that you have not foreseen. So what you would need is a platform that allows you to deploy your applications to multiple clouds, even to spread your applications across multiple clouds, that allows you to reuse your software components that you defined on these different clouds, and ideally you would want to reuse them without changing them. You want to have an abstraction layer across these different APIs that I was talking about earlier, and ideally, this tool also supports multi-tenancy. So there are similar tools out there that already provide some of the features I mentioned. For instance, Cloudify is one of these, but they don't support this multi-tenancy, for instance. So what you had to do is each developer would have to install, set up this platform on its own and cannot build on what others already did. And finally, what we found particularly interesting for the Passage project is adaptation rules. And Cloudiator is a tool that fits all these requirements. As you can see from the title, it's more or less concerned with 2 parts. The one is the deployment of applications, and the other one is with the runtime handling. So I now start with the deployment, and let's see how far we can go with the runtime, depending on the time constraints we have here. Deploying an application means that you take this application and enact it in the cloud, whatever that means. And for that reason, I first go into what constitutes an application for us. Then I tell you what I understand as cloud. This does not fit in this definition. It's much simpler than that. And then I tell you how we do this enactment by some life cycles or life cycle handlers. In order to understand what we consider an application, basic building block is a so-called component We see that as self-contained chunk of software, which is a unit of scale and a unit of failure. It's as simple as that. There's nothing more to this. This component may then interact with other components. So examples are databases, which normally do not interact with other tiers except that they are called from them. There's a load balancer, may also be a component. Or the web server, including the business logic. So this is not sophisticated. There are other modeling approaches that use a much more complex approach to this. For instance, in Passage we're using Camel. I think you've heard of that already this morning or yesterday. I think it was yesterday. And we can derive our application model or these components from Camel. From these components, we then build what we call applications. This is just the individual components with a wiring. So stick to the orange boxes. So you may have a component called Nginx, which is a load balancer, and this is wired to another component called. I'm using this Ghost block that is running in Node.js as an example throughout the talk, and this application server is then again wired to Postgres. Now this is an application. This is what is also in normal terminology an application. The equivalent to process would then be an application instance, which means that you take this application, including all its components, and make it executed in the cloud. And this means that you bring up at least one instance of each of the components. And in order to do that, and in order to realize the wiring, we have to, well, most simple example, fill the port numbers. So you can say that, well, my Nginx port should listen on, my Nginx should listen on port 88. I don't care what this Node.js listens to. I just want to make sure that it is connected to Nginx, and then Cloud Agent will ensure that there's this connection here. And maybe I also want to say, I don't really care about Postgres, but it might be a good idea to use the default port that Postgres normally uses. Okay, so far so good. Just before I dive into how we bring this to the cloud, let me briefly tell you what we understand, or what different aspects of the cloud we consider here in our platform. First of all, we have the cloud platform, which is actually the software stack that is run at the cloud operator. This is including the version, because from this combination you get an API that you can use in order to invoke this cloud service. Example would be OpenStack Juno. It's not just OpenStack, but including the Juno. Then we have the cloud provider, which is the guy or the company offering access to his resources by running the software stack. By that you get the endpoint where you arrive. Examples are RedStack, for instance, or we have two clouds in Ulm running. One is our local cloud that's operated by our institute, and the other one is a federal statewide research cloud platform that is currently set up. Finally, what I call cloud in the remainder of this talk, which may not fit any other definitions out there, is the provider or the cloud provider is seen by the user. This means there is a username involved and there are access credentials involved. Okay, in order to support multiple cloud providers, the most simple thing that we need to do is you have to hide the differences in the APIs. In order to do that, our tool mostly relies on Apache JClouds. We've done a great job in implementing wrappers around the different APIs. But we also have custom implementations for cloud platforms that have not been supported by JClouds. For instance, for the Flexint FCO, I think Craig gave a talk earlier today. We have a custom implementation of this, of our own API, internal API. Okay, other things that we take care of, and that you also have to take care of in order to ensure a deployment of applications, is the technical locations of a cloud. For instance, this PW cloud that I mentioned earlier is an OpenStack cloud, so it uses the OpenStack locations that consist mainly of two layers. The first one is what OpenStack calls regions, and the other one is what OpenStack calls availability zones. Apart from these technical locations, we also have physical locations, geographical locations, where these OpenStack regions can be mapped to. So the MA stands for Mannheim, UL stands for Ulm, and FR stands for Freiburg. All of these are then in the federal state of Baden-Württemberg, which is in Germany and in Europe. But this is not the whole truth, because you may want to have availability zones that reside in different geographical locations than other availability zones in a region, or you have other cloud platforms that use a totally different schema to their technical locations and also to the geographical locations. Last but least, not all locations are required for deployment. So in OpenStack you may put an availability zone there, but you don't have to. And in order to have our tool capture all of these differentiations, we came up with a meta model where we introduce a top level. We just give a name and define a driver, which is the library to access to the cloud. And then you have a hierarchy of technical locations where again have a name that states whether this is mandatory for deployment or for accessing entities on the cloud, and where you may want to put where you can state whether you can attach a geographic location or not. So in the case of Juno, we have the top level entity, which is OpenStack Juno, and you say the driver is JClouds and uses the OpenStack version for JClouds. In the location hierarchy, well, the first level is a region. It is mandatory to put this region in order to deploy or to start a virtual machine, for instance, and well, it is required that you put a geographical location there. Otherwise, well, the availability zone is not required for accessing resources, and you can put a geographical location, but you do not have to. There are other cloud properties, for instance, summarizing. Cloud providers, driver, and locations. So location, driver, and endpoints, should either read or talk, are cloud provider specific, so they're more or less static. Images and flavors in a cloud platform are not that static, because different users may see different images, may see different virtual machine types, may see different hardware flavors. And there are also some other stuff like virtual networks, security groups, and stuff like this, but I won't go into this today. In order to deal with the different uses for images and flavors, we introduce, well, the first is to access the cloud as a user. So for each user of our platform, here at Joerg Domaschka, we can put access credentials. So here for the PW cloud and maybe for Amazon, and this links to, in the data model, to the providers, and on the providers there are the other entities that you just saw. Once you add a new credential, then Cloudiator will start harvesting the available data from the cloud provider. So it will read the available locations, the available regions, availability systems, images, hardware, flavors, and whatever. And it will repeat that periodically and fill its own database that describes all of this. So, for instance, after having added my user there to my credentials there to the BW cloud, I may end up with an image like this, and two hardware definitions, and if one hardware definition goes to a one-core machine, the other one goes to a core machine, and these two are in original form. And there is another user on BW Cloud that has only access to this hardware flavor, but not to the other ones, because these are my private ones. So you can see here, there is meta information available for the images as well. So in that case, this is a Ubuntu 14.10, and in that case, it's an Ubuntu 15.04. And for capturing all the operating systems, we build a operating system hierarchy in our data model that we adapt as necessary or enrich as necessary. In order to interact with the system, we will be going just a quick impression, so it's rather slim, nothing fancy, but it does what it's supposed to do. Summarizing what we got so far is 6 components in our cloud platform. Well, apart from the user interface that is REST-based and web-based, we have a part that deals with components and applications. We have a part that deals with user and accounts, one part that deals with cloud providers and flavors and images, and we have entities that deal with accessing the actual cloud platform. Okay, now I'm finally at the stage where I can explain to you what happens when you deploy an application instance. What you have to do first is you create your virtual machines and then put your components onto these virtual machines. So there's nothing fancy involved here, no magic at all. Instead, we expect that people or that anyone who needs this magic uses our API to build a high-level software system that then does all this virtual machine creation automatically. This may then result in something like this setting, where we create one virtual machine in the Amazon cloud, where we deploy the Nginx as a load balancer, and we came up with 3 further virtual machines. One of them is used for Postgres database, and the Node.js is deployed on virtual machine 2 and 3, and also on virtual machine 1. Now, in order to bring up the system, we need to execute logic. Mainly, we have to install software, we have to maybe adapt configuration scripts, we have to start the software process on the virtual machine, and later on, we have to figure out whether this component instance has started correctly or whether it has crashed and it's not running anymore. Finally, whenever we add a new Node.js or Ghost instance, we may want to adapt the Nginx configuration in this example in order to tell the load balancer that there are further instances available. For each of these steps, we introduce lifecycle handlers in the system that are invoked at particular moments in time and are user implemented. And these lifecycle handlers are then supposed to execute the necessary actions to run the application. Okay, 5 minutes, so I'll be quick. Only 20 more slides to go. For each component, we can put several lifecycle handlers. So in this example, you see install handler for Nginx, one that is run on Windows systems and one that is run on Linux systems. And you have this bash or bat script, and you have this update handler that is implemented as a Java class and can be run on both Windows and Linux. Technically speaking, what happens is that The Cloudiator will start this virtual machine. Okay, we got that far. We'll then install a software component called Lifecycle Agent on that virtual machine and tell this Lifecycle Agent to start, well, Nginx by running all the handlers. The Lifecycle Agent will then create a Docker container on this virtual machine and here run the lifecycle handlers until Nginx is up and running, operating correctly. This closes the first part of my talk. Okay, let me just skip very, very quickly through the second part. So the main idea is that saying that basically your deployment is not useful unless you know what's going on in there, whether anything is overloaded, whether you need to change something. And the key to this is monitoring. And we added a rather flexible monitoring infrastructure that is again controlled by something we call a monitoring agent that is also run on the virtual machine. And that only produces raw data. Raw data basically is useless unless you do some aggregations or some mining on it. And this aggregation is then done by some aggregators that may run on the virtual machine, that may run on the Cloudiator home domain or somewhere else. Let's just skip this. And eventually, so the components that we end up is before, but we have a data collector and aggregators as well. Finally, just to tell you that you can define your own monitoring, your own probes, your own aggregation rules, and that we adapted the Passage scalability rules language, which is a rather powerful language where we describe patterns that define when you want to scale up or scale down or in and out application components. So we have the SRL engine, which basically interprets the scalability rule language and compares this with this monitoring data that was just collected. Concluding, what Cloudiator offers is the way to a simple application specification mechanism, a mechanism to instantiate your application across different clouds, a mechanism to control and adapt the application operation by monitoring and by adaptation rules, and it also provides a way to control or to manage your cloud providers and to have multiple users and control the access rights to these users. All of this is down to earth. As I said before, we don't do magic. All of this is open source. We hope the project is hosted on GitHub. And our roadmap is to release a version 0.1 by the beginning of August, which is in a few weeks. This version will then have been tested by 4 Passage use cases, and for version 2 we will integrate Windows support and introduce a bit more robustness. And finally, for version 3, which should be towards the end of the year, we want to integrate stateful migration of instances across cloud operators. If you want, or if this sounds sexy to you, have a look at the project, let us know what you think, and ideally contribute. Thanks very much.
Are there any questions?
One question. Why did you redefine the notion of a cloud? By will? Sorry? You did?
You basically said that you are not relying on the typical definition what the application is, what a cloud is, and so on. So why did you do that? You started with your definition of what an application is, and you often said this is not the typical notion of an application, similar to for cloud. Why? Just to get more publication through? You redefined everything, then you...
Not at all.
Okay.
No,
I'll give
you
you another. Because we fixed it, I think we had.
Sorry.
Yes. You may take this.
So, there are two aspects. The reason why I decided to use the term cloud in a different way was that it dramatically eased writing the paper, because I didn't always have to say cloud and cloud plus the username and the credentials. That was the first thing. And for the application, I didn't find a typical cloud application specification. So there are multiple models out there, but none of them seems to be the one to use. That's all, basically.
I have a follow-on comment to make on both definitions. If you look at the terminology that's established in software architecture and software engineering, and there's Gruchten's 4+1 viewpoint model, and what you call application or components are infrastructure components, and it's deployment or operational viewpoint. A load balancer, in my mind, as an application architect, is not an application or an application component. It's an infrastructure middleware component that supports the application. The Java code implementing the shopping bus, that's an application component. So you're confusing users with this terminology. So that's for the application. You have infrastructure components.
Yeah, I get the point, but for our platform, we don't. It doesn't make any difference.
If you reach out to users, right, and you send the wrong message, it means you're dealing with infrastructure components, not application components. And for cloud, I did the mental test, right? Tomcat meets your definition of a cloud software, or JBoss, the JE application server. You read your cloud definition. Any middleware that hosts application components is a cloud in your terminology, and then you get confused users. Nothing wrong with your research results. It's just terminology and expectation management.
Okay, got the point. Thanks.
Any further questions? Okay, thank you for your Now there is a coffee break. Let's hit for 20. Yes, sorry, plus PhD sessions, again, poster session. And let's come back in 20 minutes. Is it okay? Yeah, thank you.
Okay.
Yeah, I hope so.
It's really effective.
Hey, could cheese pan.
I can eat what we have.
Cheese pan.
It's